Good evening. I'd like to call the meeting of Standing Committee of Economic Development and Environment back to order. My name is Jackie Jacobson. I'm MLA for Nunukput and chair of this committee. Today, a Standing Committee of Economic Development and Environment is receiving a public briefing for Mr. Jai Zachary, President of ElectroMotion Energy. Mr. Zachary was invited to present before the committee this evening. As chair of the committee, I encourage members of the public to reach out to their MLAs and standing committees for similar presentation and opportunities. Today's meeting is live streamed on the Assembly's social media. To respect physical distancing requirements, witnesses will be attending by video conference. I would like to remind all the members and our witness, all comments and questions and remarks will need to be directed to myself as the chair. Both members and witness will wait until I recognize them by myself as for speaking. I will now ask members to introduce themselves for the record.
Ron Bonatruz, MLA for Techo.
Kevin O'Reilly, Frame Lake.
Rylan Johnson, MLA for Yellowknife North.
Ms. Knockleby?
Ms. Knockleby. Katrina Knockleby, MLA for Great Slave.
Ms. Cleveland?
Caitlin Cleveland, MLA Kamloops.
Thank you. And our committee staff is joining us here tonight. Thank them for being here and making this possible. I will now invite Mr. Zachary to proceed with any opening or comments you may have to deliver with your presentation. I'll remind you to try to keep your presentation to 20 minutes to allow time for questions from my committee members. Go ahead, Mr. Zachary.
Thank you, Chair. Before we begin, I'd first like to thank yourself, Mr. Jackie Jacobson, for this opportunity to present to the Standing Committee on Economic Development and Environment, and also I'd like to acknowledge the traditional territories of the Dene First Nations people where this presentation is being virtually held. Thank you. I'll start the formal, just a sec here. All right, let me know when you can see your screen. I'll just share. Are you able to see presentation?
No, we can't see your presentation yet, Mr. Zachary.
Okay, just a moment.
Might be on our end too here. Just one sec.
How's that?
Yes.
Excellent. All right, thank you. So we're just going to go over a few things here to preface the Revolution Housing Platform and discuss a bit of things, what led to the Revolution Housing Platform. And these are the overview topics and categories. So the heat and electricity relationship, which is something that is quite prevalent. So I like to always say it's all about heat and, of course, electricity. So electricity is generated globally with thermal methods, coal, natural gas, diesel, etc. And you have your transmission all the way to where you get to your home or the demand site. So this images just reflect what is really going on in the dynamics. So according to the United States Department of Energy, more than 2/3 of all the fuel used to generate power, of course, is lost as heat. And this is, again, all around the world. This is an example of what's happening in the Arctic, Northwest Territories. We talk to heat pollution being released through power generation. Everyone's familiar with that, and this one's in Pawituck and Vic. And that really brings us to then, of course, the relationship between the home, and heat as well. So all that thermal energy that's normally being or ejected into the atmosphere, that energy would really give us all free heat and hot water if we're able to capture that heat during electrical generation. This here, the last time I was in Pawlatuck, is their energy profile. Excuse the photo. It was just as I went into the elders. But you can see here, 2/3 of the energy is going into the atmosphere, and that energy will go into the ice, into the permafrost, into the Arctic. And if you really look here, that 2/3 heat losses when you're generating electricity really is more than enough to heat your home if we're able to capture and utilize that energy at the home. And that then brings us to the relationship between the environment and this thermal pollution that we talked to. So using Pawlatuck example again, we calculated over the last 20 years, enough heat has gone into the atmosphere to melt and into the ice to melt an iceberg the same size that sunk the Titanic. Significant amount of energy going into the atmosphere and into the ice and permafrost. Alternately, we have another visual where the Empire State Building. So that's 1.5 times the mass of that Empire State Building. That's just a little community of 300 people. And this is what brought us to the Revolution Housing Platform. So the Revolution Platform, the Revolution Energy technology here is really a combination of the Revolution, what we call here, the core. That's basically replacing all your heating, hot water, air conditioning technology, and it's generating electricity as a byproduct. And that is mated and merged, if you will, with our housing platform, which is a flat pack on-site assembly system. That is essentially what the housing system is. Now, of course, everyone's familiar with the typical issues at play with typical housing. We have a lot of mold problems. We have a lot of construction issues, distribution, time constraints for weather and such. So these are some of the challenges we're looking to eliminate and to control. So the Revolution Housing system here, not only is to talk about generating energy, but we're looking at eliminating these problems with the mold, the black mold, the distribution of materials, fast setup. That's the rapid housing development. This here is a few images of what our models are right now that we're out to offer. These are some of the highlights. We have triplexes, we have seniors assisted living, we have 4 bedrooms, 3 bedrooms, 2 bedrooms, independent setup. I'm just going to play here now what is actually out here that we assembled. This is an example here of the housing platform and how we're able to really eliminate or rather dramatically reduce skilled trades. So, of course, a lot of times you have distribution issues, you have construction issues such as stick, a lot of issues with regards to getting people to the site. So what the Revolution Housing Platform is trying to do here is to eliminate these bottlenecks. And as you can see by the video here, this is out front of our facilities. And we're utilizing SIP panels, so it's very precise CNC. You can actually see we had to take it apart because we had the blueprints upside down, but we lost a day there. But the housing platform is really meant to be rapid deployment and to utilize local labor and minimal skills that we can utilize at the site in the community. This will eliminate a lot of constraints for trades, and at the same time, we're going to be able to provide an efficient and very high fit and finish platform for the housing platform. So you can see they're just regular people. We have some people here that were some students, university, people off the street kind of thing. No real skills, if you will, in terms of assembly. This is our first kind of prototype that we assembled. And really, once you have a crew that would show up that would be able to utilize local people and hire those people locally. And that way then we're able to then utilize a rapid deployment and flat packet. You'll see it up here next, coming up where that we did use a crane, but that was something that we've managed to eliminate because that is another constraint for assembly. So we're still able to actually now assemble without a crane or without any heavy equipment. Now, one of the advantages is not just a square box. There's some engineering principles going into the ventilation system that we've developed as well. Things such as the stack effect, where you have static energy and things like this. This here is able to really eliminate, because what's going on here is we're not only providing rapid housing and good fit and finish, but we're actually also able to provide energy to the local community and to that house. So this is a house that actually is able to produce energy and not only reduce its energy through its efficiencies. And that brings us to what we call virtual power grid. So people probably heard about microgrids. This virtual power grid is what we're talking about with the Revolution Housing Platform. So as we talked about earlier, thermal generation, what required is you have a 3-to-1 loss of energy. So when you're using electricity at the site, and this model here is one example, because of the 3-to-1 energy losses, that means the power generation station has to consume this much energy at a 3-to-1. And that's because, again, like I mentioned and showed you the image earlier, we're looking at all these heat losses through power generation and then through distribution. So that central generation and distribution model is really what's at the heart of all these energy losses and the thermal pollution that's going on. So by deploying Revolution Housing platform, we're actually able to gain a 3-to-1 advantage with regards to the energy losses and eliminate those losses. And that's where the real power of the Revolution Housing Platform is. So even though we're able to rapidly deploy the Revolution homes and utilize local people for setting it up, the real beauty of it is that we're looking to harden and to reduce the energy losses and the diesel consumption as well, and get that 3-to-1 losses or reduction of thermal pollution and greenhouse gases. So let's talk a little bit about the Revolution cost analysis. So here's one example utilizing, again, the numbers that we calculated with the Polytuck installation. The amount of fuel that's going to be consumed on an annual basis here is the top part here with a typical frame stick home, and then the bottom section here is with regards to the Revolution home. And the reason why you're seeing such a dramatic reduction is because of the value that we're producing, which is the electricity and the 3-to-1 advantage for the fuel consumption. So there's that energy sustainability that is really going on here. Quite dramatic. Here's another example here of the numbers involved. And the reason why there's such a dramatic, again, difference is because we're shifting the generation of electricity from the central generator, which has all those losses, to the home, and we're only going to generate electricity when we need heat and hot water. And that's really what's going to happen. So it's like a furnace, if you will. The Revolution technology produces electricity as a free, quote, byproduct. And that's a 3-to-1 advantage. So you have this dynamics going on. So then someone's home goes into heat cycle. That means 3 homes disappear from the grid perspective when there's a heat cycle. And that everybody takes turns heating their home and making hot water. And that's where the microgrid or the virtual power grid comes into play. Here's an example over 20 years, the differential between the maintenance and cost comparison for capital and operating costs. Quite a dramatic difference. So as you move forward in time, you're going to be able to recoup and even capture additional savings and energy utilization with this system. So here's again another little bit of cumulative difference. So this, if you really want to stop and think about it, the Revolution Housing Platform is the only technology that allows you to actually produce energy, not only reduce your energy consumption. So a lot of the times as we talk about rolling out homes and adding to the inventory, what's going to happen is you're going to have this vicious circle or cycle occur where now you're going to have to start to add to the infrastructure, and then you have these bad dynamics that create where then you have additional losses and more diesel, in this example, being consumed. So the dramatic differences as you move forward in the stick home and a Revolution home, the cumulative advantages and cost benefits are quite substantial. Now, not only is it advantageous to the actual installation in the home, but we're looking also at the community. So as you deploy more Revolution homes in the community, you have this 3-to-1 benefit and advantage that is going on that benefits the community, benefits the utility, and of course it benefits the site itself. And in this instance here, you can see the amount of ice that is prevented from melting because we're eliminating all that thermal pollution, never mind the greenhouse gases and the fuel consumption at the central power station, but we're eliminating that thermal energy going into the ice and into the permafrost, and this is quite dramatic. So the value to the community as you deploy more, this is based upon the, we did a year-long analysis and study with the federal government about remote and northern communities. And these numbers here are based upon deploying the number of homes that are required in Polituck is one example. And so these numbers are calculated on the benefits that Polituck would recover as a community with the Revolution Housing Platform by deploying Revolution homes instead of actual typical stick homes that do not produce energy. Quite dramatic. The job creation, I should just speak to that for a second. That's regarding because, again, with every home that Revolution is deployed, the technology is going to require oil changes now and then, some service work. And so what we'd be doing is within a community is hiring an individual that we would train, or more than one even, that would then maintain and manage the Revolution Housing Platform and the system that we're going to be deploying. Now, just to finish off a little bit here, right now in our state, we've been at this for many, many years. R&D, we've been running, you can see a photo here of the unit that I showed earlier setting up. We have multiple facilities for manufacturing, and we're based here in Summerland, British Columbia, and we're ready to roll with regards to being offered an opportunity that would love to collaborate with the Northwest Territories. And that's about it for questions and answers now. Thank you.
Thank you, Mr. Zachary, for that presentation. Are there any questions or comments from the committee? Questions, comments? Mr. Bonatrouche?
Merci, Mr. Chair. And merci to you, Mr. Mr. Zachary, for your presentation. It is quite a bit of information to fathom. Some of your prefab models, I think we've had 2x4 construction back in the early 70s in the north here that were just prefab units put together. But the 2x4 construction, I think in your presentation you did mention 2x4 construction, but at the same time I see your thermal energy or your building envelope insulation values, and to get to the values you've got, you're using probably 2x6 construction on most of the buildings. to get the RSI 5 value and the 7 for the roof, the ceiling panels. They're thicker and stuff like that. So do you offer these in 2x4 or various size dimensional lumber? I'll ask that question.
Yeah, thank you, Mr. Bonatrouge. Mr. Zachary.
Yes, thank you for the question. The SIP panels are created in a factory. We design them in CAD, CNC, produced at the factory, and the stick lumber is minimized. The panels themselves are, if you will, sandwiched. And I don't know, did you receive the package that we provided earlier with regards to, there's a document there that talks to the SIP panels, but the actual stick framing is minimal to non-existent. Really, they're both panels that go together only one way, and those panels then are bonded by a 2x6 or even larger, so the panels can come together, and then they're bonded, either glued, or in some cases here, what we did with our demonstration project out front, we did not glue them together. We sealed them so that we could actually unscrew it and take it apart. So we could actually disassemble that home with the SIP panel technology versus stick construction like you would a normal home. Did that answer your question?
Thank you, Mr. Zachary. Mr. Bonatrouge.
Yeah, I understand that now. So it's just like a foam core insert. I just had my question here and I kind of almost forgot. So I understand you're saying that you have joinery and you screw them together. Have you ever had thermal imaging done at the joinery to, like, you're looking for heat loss? I'll ask Mussy.
Mr. Bonatrouge. Mr. Zachary.
Thank you. Yes, we have. We have multiple thermal images. We also employed a technology that would call it an aerosol that would go into the environment before you would say have somebody move in, and it permeates the structure and seals any kind of leaks, any kind of area that would be maybe missed during assembly and construction. So that's a great question, and we have multiple, I guess, energy audits that we did on them. I think in the redacted document I provided, it talks to the air change per hour, if you will, and the sealing of the structure's envelope as part of what you're inferring. Absolutely. So we were able to really seal it to down to about a 1 air change per hour.
Thank you, Mr. Zachary. Next on the list, I have Ms. Knockleby.
Thank you, Mr. Chair. Thank you for the presentation, Mr. Zachary. I'm an engineer, but not this kind of engineer. So I deal mostly with rocks and water, etc. But I did take a cold regions engineering course not that long ago, which made me realize that my 1970s modular home is not very well built for northern climates. So I'm really excited to see this presentation, and I look forward to delving into this package. I didn't have a chance to beforehand. So and just getting some more of the technical specifications of how this works, and you may actually have a future customer here on your hands. My question is regards to the materials your buildings are made out of. One of the issues we have in the north is that we deal with a lot of waste from old buildings, etc., hazardous materials, asbestos, things like that. So I'm just curious to know what is the lifespan of these buildings, and is there any sort of special considerations that have to be taken for either for anything that's produced during construction, doesn't seem like it, or when they are needing to be dismantled eventually? Thank you.
Thank you, Ms. Knockleby. Mr. Zachary?
Thank you very much for the question. Thank you, Chair. That's excellent. We would all love to have things last forever, and I can't promise that, absolutely. But what I can tell you is that the materials that we would try to use are off-the-shelf technologies or off-the-shelf building materials. And what that's going to allow to do is be selective in terms of making sure nothing is going to be hazardous. The SIP panels themselves, this is very standard, straightforward technology that's out there. And what it's doing is closed cell foam that is inside the two panels. So think of like, I guess maybe I'm hungry, but like an Oreo cookie, right? With the cream yummy inside. And that is something that is possibly it's excuse me for the analogy, but that's right. So one of the things that we try to and have done with our housing platform is take a holistic approach on the I guess matter. So I probably may have already gathered, we're looking at the sort of hand in glove. You have your housing, you have your energy needs, and then you have your electrical grid. How all of this works right now is very siloed, and so we've really approached it so that it's really a complete holistic life cycle approach that would have these benefits that we like to call revolutionary. So to hopefully specifically to answer your question though, the product and the materials do not off-gas like you would normally, as one example, have with a new construction. And in terms of cladding on the outside and the interior, that's really up to what I guess the end user, the person purchasing the technology would want, and that's something we can accommodate for sure. But the base core itself is very robust and not hazardous in that sense.
Thank you, Mr. Zachary. Mr. Knockleby?
Thank you, Mr. Chair. Mr. Zachary, you hit on quite a buzzword that we use often up here in the north is siloed. So it's nice to hear that this is more of a holistic approach, which I think is more needed up here. I guess my question next would just be around, do you anticipate that you would be looking to set up or establish businesses in the north? One of our major issues and concerns is that we lose money often to southern companies. I'm glad, I know you're in BC, which is my where I grew up, so I like that. But I do see that there, is there opportunity, or has your company looked at exploring ways, and maybe this is out of the realm of this conversation, but of partnerships in the north? Thank you.
Thank you, Ms. Knockleby. Mr. Zachary?
That's a great question. We really want a long-term relationship. And just to give you some background as to where we're at today right now, many years ago, I came up at the invitation of the Northwest Territories government and had a tour of the Arctic. I also had Jackie himself came down to here and saw our facilities. I even was honored to have the Premier McLeod, Uncle Bob, like he said, the last email I got from him. And what we really did was looked at how we can create a technology that would solve a lot of these issues and problems, and at the same time have a long-term, I guess, a partnership. And we've already reached out to, just further to that, we've already reached out to several groups in the Northwest Territories region, both from the federal government has introduced us, great opportunities there. And yeah, we want something that's long-term. We can see, and the fact that we're going to need some sort of presence up there, just as I mentioned earlier, where we're looking at having to have people on site, on the ground in the communities, because we are running a mechanical system in some regards. So even though, as an example, the generator is producing heat and electricity, it is mechanical, and there will be some servicing required to it. So that's where I talked to in my presentation the community benefits, because we're going to be spending long-term dollars, and really what it's doing is, I would say, is it's shifting the losses and the energy costs from all that diesel that's going up the smokestack, if you will. We're capturing those dollars, and we're then redeploying that money within the community. If that makes sense, great. Okay, thank you.
Thank you, Mr. Zachary. Next on the list, I have Mr. O'Reilly.
Thanks, Mr. Chair, and thanks for the presentation. And look, I'll confess to not knowing anything about buildings or anything. What is the energy source within the envelope? Is it from what I've read here, it looks like it could be natural gas based, which I guess Tuck is fortunate in that it does potentially have some local natural gas, but is this like a furnace of some sort, a boiler system? What's the energy source in there, and does this involve any kind of battery storage? Look, I get the efficiencies of having the unit in your home and capturing all of the energy right there. That makes lots of sense, but I just want to know a little bit more about the energy source and what the unit itself looks like and what it does. Thanks, Mr. Chair.
Thank you, Mr. O'Reilly. Mr. Zachary?
Thank you. That's an excellent question. So the Revolution Energy Technology, we call it a core, and what it does is replaces your furnace, hot water tank, and I guess air conditioner, if you have that even up there. But it contains heat pump technology as well as electrical generation, or called CHP, combined heat power. So what that means is instead of having all that equipment that you normally would have within a home, taking up valuable living space, the Revolution is contained, and as I mentioned, the components are contained in a little area in the corner outside of the living space of the home. And what we use is the opportunity, either diesel or natural gas or propane. So when I say either of those, the Revolution technology is really flexible in terms of what type of generation system is available, and the fuel source that's available at the certain communities that would be deployed. So what that means, if there's natural gas or propane is not available, then we would deploy the Revolution technology with, say, a diesel generator, because that's your logistics and that's what's available. Now, what that means is you might say, well, we want to get off diesel, which is a great initiative, but this is going to be a process. This is not going to happen overnight, and so really it's an incremental movement towards alternate fuels. But the immediate need, of course, is you have a diesel. That's what we have to work with. Therefore, the Revolution can come with a diesel generator. And really what we're doing is we're like I said, say if we use diesel, then we're getting a 3-to-1 advantage and benefit versus, say, the central generator for the community. So what that means then is you still have a 3-to-1 advantage and energy efficiency and cost benefit. But so I guess I don't want to confuse it, but the Revolution is flexible with regards to what fuel source is available.
Thank you, Mr. Zachary. Mr. O'Reilly.
Yeah, okay, thanks. So I know that you've got, it sounds like you've had your demonstration units in Summerland for 9 years, and you probably got loads of data for that situation, but that's a long way from, say, Paulatuck or Fort Providence or Yellowknife or whatever. So are you looking to get like a demonstration unit in a northern location so that you can try this out and see how it works? It sounds interesting that you could have this kind of off the grid and ship it flat and so on. That all sounds interesting. I guess I'm just wondering about having this trialed or demonstrated in a northern environment, and collecting some cost data around, the capital cost up front and then the O&M over time versus a traditional housing unit. Because I think that's what we kind of need to get our hands on to convince others that this is something worth trialing. But, it certainly looks interesting, but I think we need a demo unit and some real live data over a period of time. Thanks, Mr. Chair.
Mr. Riley, Mr. Zachary?
Yes, thank you for the question. That would be fantastic. We would love to work with you, depending on what your needs are. And again, we're looking for a long-term relationship. So, we'll start slow, work our way forward. That's great. I guess what I would say with regards to demonstration project, we always kind of comment that we'll get one unit up there, we do the demonstration, and then when you have your first power outage, that's will be the only home that would have electricity and power and heat. So that's the other alternative, or the advantage with the Revolution Housing Platform, is the fact that when you do lose power, it defaults, breaks the connection to the grid, and you're basically on like a backup generator with heating and hot water and power.
Thank you, Mr. Zachary. Next on the list, I have Ms. Cleveland. Mrs. Cleveland.
Thank you very much, Mr. Chair. Miss MLA Cleveland or Miss Cleveland is fine. Thank you very much for the presentation, Mr. Zachary. I really appreciate it. The first question I have actually was in regards to a unit being on the ground here in the Northwest Territories, and if you had data on that. And so I'm glad that MLA O'Reilly brought that up. And I think that given that building in the North is so different from BC, it's really important to have that kind of prototype unit to show that this works in the Northwest Territories. But given that MLA O'Reilly already asked that, my next question would be, given that building in the Northwest Territories is so different, especially based on mold and heat loss and such, in such a harsh and unforgiving environment, and also based on the fact that you say it doesn't need trades in order to put these units together. What type of a guarantee comes with the units then, and what is the typical lifespan of one of these homes? Thank you.
Thank you, Ms. Cleveland. Mr. Zachary?
Thank you very much. I'll start with the lifespan. It's a typical 50, 60-year lifespan. The structure itself, termites, molds, these kinds of rot can't really get into the panels themselves. So there's that one advantage too. Termites doesn't affect the structure itself. The other thing too is with regards to the, let's talk about molds, the ventilation system. So we've developed a very unique heating and ventilation system that will have 100% saturation of the airflow. So one of the things, if I can be a little technical here, everybody knows you have the heating coming out of your floor, right? That's typical. It goes into the room, and what you then have is what's called stack effect. So the heat rises, hits the roof, and then it's different degrees of temperature, if you will, in the environment. And so what we've done is developed a technology such that if where normally you would go to, say, by the window, you would go into the corner of the room, you would feel a real temperature change, right? Especially if it's 60 below zero versus in the middle of the room versus near the wall or near the corner or near the window. So what we've developed is this ventilation system that circulates and disrupts, they call it the stack effect. So what that means is you could be in the middle of the room, and then when you go to the corner or go to the wall where the window is, the temperature is the same. And why I say that is because, again, our ventilation system. And that's something we can get into. I can show you imagery and such. But that then also is a more comfortable feeling. And also because there's 100% saturation and disruption of that sort of stack effect, molds are not able to grow. Moisture, we control the content of the moisture, of the volume of the air. And additionally, what you like to learn is that we've also figured a way to sterilize the air using UVC. So what happens is, again, I'll get a little more technical, it's called air change per hour. That's in the room itself. So the air in the room is not static and doesn't sit there. It's circulated and refreshed and sterilized at the same time. So, and let me give you another example too. The tanks are inside the structure itself. They aren't exposed to the atmosphere. And part of that process is to prevent them from freezing. And at the same time, all the plumbing that's inside the structure and our Revolution housing platform, that is protected from freezing as well because of the way we have developed our ventilation system. So your environment where you are living and walking around in the structure, that is isolated. There's an isolation system, if you will, from the exact cold. So actually your floor is kind of warm, if you will, like a second-story floor.
Thank you, Mr. Zachary. Ms. Cleveland?
Thank you very much, Mr. Chair. I appreciate that. One of the most important kind of pieces of building in the Northwest Territories that we hear a lot about that I don't think is as prevalent in BC is the vapor barrier. And so I'm wondering, given that the walls come up in sections, how is the need for a vapor barrier addressed within the models of the homes that that ElectroMotion has? Thank you.
Thank you, Ms. Cleveland. Mr. Zachary?
Thank you. You're correct. There is vapor barrier and there's sealing involved. The units come with HRV because we are sealed so well. So the structure itself has about 1 or less than 1 air change per hour. So because of that type of sealing, we're requiring to have HRV to refresh the air. And part of that process then, when we recirculate the air before it's refreshed, we also, again, mentioned earlier, sterilize the air. So that way then we're able to deal with any humidity and moisture. The envelope on the outside is using the aerosol earlier I mentioned, that seals it. And then we have a house wrap that goes around on the outside as well. So very, very typical construction methods for that. Did I answer your question?
Mr. Zachary, Ms. Cleveland?
Mr. Chair, if I've got additional questions, but I don't know if you want me to go back on the list.
I have, I'll put you back on the list for round 2. First to go,
Thank
but
you.
I have Mr. Bonatrouche starting it off. Mr. Bonatrouche?
Let's see, Mr. Chair. Mr. Zachary, I'm really getting kicked in the britches really well here regarding your energy unit. You're saying it's a self-contained generator. It's probably a small size from the pictures I see. That all the energy is being produced is being made by that generator, and you're also generating heat. So I imagine you're using heat recovery system. Because something similar to what SSI Energy was proposing up here too, using the heat. But I'm wondering about, because you're running, whether it's on diesel, propane, or natural gas, you must be aware of our greenhouse gas emissions targets and initiatives that we have up here. Specifically, since I've been touting it anyways, and some other members here too, the wood pellet boiler technology to cut greenhouse gas emissions, plus there's great energy savings in that regard. Nothing can beat that, not even natural gas. But it's a matter of incorporating it. So, and I know that I'm just wondering about that. Is this a self-contained unit? I know it still has to go through our energy division for review, if anything. We don't have the ultimate say here. But I'm really wondering if you could speak more towards that energy system, that compact system that you're touting. If I could start with that, Masi.
Thank you, Mr. Bonatrouche. Mr. Zachary.
Thank you. If I understand correctly, you want me to expand on what the Revolution the core technology includes and how it works? Is that my understanding?
Yes.
Okay, great. Thank you. So the subsystem, which we call the CHP system, is called combined heat power. So just as if you had a motor that's running combustion, or the big generator that you have in the middle of town, that generator is producing heat. So the electricity is really 1/3 of the energy you get out of the diesel fuel and energy. So that what it is that thermal energy that's being lost, and that's where we have correctly. You mentioned heat recovery system, and we're so good at that we actually condense and create condensate as part of that process. So that energy then that we capture then goes into either potable water or space heating using a glycol heating loop that we kind of like a boiler, if you will, and that then heats the house or heats your hot water. So the electricity then becomes a free byproduct because we're after the heat, and then that electricity then goes to the home, and it seamlessly synchronizes. Then any surplus electricity would then go out to the community grid, and then it would be consumed by the neighbors in the community. So that's where the advantage we have for greenhouse gases and energy utilization, because with every kilowatt of electricity that is generated during that heating process, eliminates 3 kilowatts of fuel energy and all the greenhouse gases and all the thermal pollution that's going on at the central generator. Does that make sense? I can bring up a picture, and I like pictures, but point to stuff. Would that help? Or if you have I think the one document there that was provided in the package talks to the virtual power grid. I believe there's a document there that we provided.
Mr. Zachary, Mr. Bonatrouche.
Yeah, must see for that. I don't pretend to know anything about electricity generation and the systems that you speak about, because you're saying there's condensation that's being used. So then right away I think about mold when you're talking about that. Then being a self-contained unit, because a lot of our communities up here are on an electrical grid. And you're talking about excess power going back into the grid. I don't think our power companies entertain that idea anymore. That's something to consider up here. But I'm still probably not sold on the whole system at all yet. Especially when you got generator running on diesel, and we're looking at greenhouse gas emissions, something that you haven't alluded to. But at the same time, we don't have any of your units here in the north, which I guess is pretty critical for us to see something that's actually on site and weathering our storms up here, especially with the little generation kit. But more of a comment than anything at this time, Masi.
Thank you, Mr. Bonatrouche. Mr. Zachary, I'll allow you to reply to that.
Yes, thank you. Again, we would use diesel if that's the only fuel source that's available. Our preference is to use natural gas or propane. So if it's possible, that's what we would prefer to utilize. Now, if we do have to use diesel, then at least we're getting a 300 or 3-to-1 advantage versus the diesel that's being consumed at the power station. So what you have, as you mentioned, there's a grid, there's a central community power station, and what's going on there is, as I showed earlier in the picture, most of the energy that's being consumed by that generator is diesel, but the energy is then being lost as heat at a 3-to-1. So what that means is when, yes, the Revolution would use diesel, but it's only going to use diesel when you need heat. And what that does then, at a 3-to-1 advantage of reducing the amount of diesel consumption at the power station that's in the community. So it still is a significant advantage, even if we do have to use diesel. Otherwise, we prefer, and our default is to use natural gas or propane if that is available.
Thank you, Mr. Zachary. Next on the list, I have Ms. Cleveland.
Thank you very much, Mr. Chair. Mr. Chair, I have a couple additional questions that I'd love to get answers to if possible. The first one is just in regards to Northern Labor, and I really like the information about, the fact that there was 4 or 5 people, it looked like in the video, working on a home. And one of the things that we chat about a lot is that housing is not solely a commodity. What is also important is what is happening with the people who live in the home. And so one of the really important parts of Northern housing is making sure that Northerners are actually working. And so I'm wondering if if you can just confirm for me how many people it takes for that 1 week to put a house together. And then also, is there a requirement for ElectroMotion Energy staff to come up and work on the home? Or is it just the government or the community is purchasing a housing package and not necessarily the staff that go along with it? So I'm wondering if you can speak more to kind of the employment this would generate. Thank you.
Thank you. Thank you, Ms. Cleveland. Mr. Zachary? Mr. Zachary? Start over. You're muted. Sorry.
There you go. No worries. Thank you.
Yep.
No, that's an excellent question, and I think that speaks to our long-term focus and opportunity to work together. Because what we're really trying to do, just like the previous question was alluding to with the Power Corporation, it's really a political will and a local community initiative from the bottom up, if you will, that we are offering and deploying the Revolution Housing Platform. So by all means, we would have people that would participate, look to train individuals in that community, and trying to really find and develop a network that we can utilize that would then not just work within that community, but that would then be able to go to other communities and kind of train the trainer, that kind of idea. What we really want to, I guess, be successful at doing is to enlist local citizens in the community to help deploy the Revolution Housing Platform. We designed it for that specifically so that the termination would be, say, by a tradesperson, but the wiring and such would be if you will, planned so that individuals that are on the site can, that are in the community that are not trained to, say, be electrical connector, they would basically then manage to set up the technology. We would have videos, we'd have personnel that we would be bringing up there too. And our long-term plan really is to look at creating transplantable skill sets to the different communities. Our analysis, and from what we've been told too, there's a significant housing shortage. Many thousands of homes are required up north, and really the long-term plan is to have our system as a system so that we can cookie cutter, if you will, the process in different communities. And then as we employ individuals to, as you said earlier, or about the video, they get set up. It only goes together one way. And then from there, we turn around and train individuals that want to carry on and train additional people. So, it's not just us doing it. We really want to enlist the community. I hope that answers your question.
Thank you, Mr. Zachary. Ms. Cleveland.
Thank you very much, Mr. Chair, and thank you very much, Mr. Zachary. My next question is in regards to the Revolution unit itself. So far, we've talked about kind of the whole housing package as a unit, and you are right, we do have a housing shortage in the Northwest Territories, so you have heard correctly. But what I'm wondering is the Revolution unit sold independently? Or do people have to purchase the entire home package as a unit? And then also, as far as the ongoing servicing that you mentioned earlier, is that something that has to be done solely by ElectroMotion Energy, or is that something that can then be serviced on an ongoing basis by local companies? Thank you.
Thank you, Ms. Cleveland. Mr. Zachary.
Thank you. Yes and yes and yes, or no, I should say. The Revolution technology, we call it the core or the SEHP, that technology is available for retrofits. So it would be a similar installation such that you would have a new furnace that would be installed, but the Revolution sits outside adjacent to the home on a retrofit. The other aspect is that the housing platform comes with the Revolution technology as part of the package. So that's where the yes comes from. In terms of no, we're again looking to partner with the communities such that we can train people to do the servicing rather than exclusively ElectroMotion personnel. So really, I see that as a long-term positioning and strategy that we would partner with the communities and individuals within the community to service the equipment. So that's, I guess, how I would approach it.
Thank you, Mr. Zachary. Next on the list, I have Ms. Knockleby.
Thank you, Mr. Chair. Can you hear me all right, Mr. Chair, now that I'm on the phone?
Yes.
Okay, thank you. I wanted to come back to Mr. Zachary. You made a comment earlier about how the floor would feel like you were on a second floor building, and that sort of made me think about or twig to our permafrost issues, which you've talked about in respect to heat loss from a building. However, specific to the foundation types of these buildings, is there a heat loss through the floor, and could they then be just installed in a typical foundation? Can the unit be brought in and placed on an existing foundation, or does something need to be done to prepare for the unit itself? Thank you.
Thank you, Ms. Knockleby. Mr. Zachary.
Thank you for the question. That's a very observant question, too. The isolation of the living space is greatly removed from the permafrost. That's one of the things we talk about, the thermal pollution. We've developed our system to really isolate the environment from the permafrost to minimize any effect on it. We prefer to see a foundation such as pilings, but if there is a concrete foundation that is certainly available, that is something that the Revolution Housing Platform could be, or the structure can be placed upon. But my understanding is, because of the permafrost, pilings are really at least what the engineers tell me, that's really the way we need to go about installing the foundation is with pilings. Did that answer your question?
Thank you, Mr. Zachary. Ms. Knockleby.
Yes, it does. So just to paraphrase or clarify, there is no, it can just be placed on a conventional existing type of foundation. And yes, you're right, pilings are better in the north. And more we're seeing that slab on grade isn't even being accepted in areas where it had been before. So thank you for that. I don't have any further questions.
Thank you, Ms. Knockleby. And also what we're using up north is space frame that they're using, so you're not having to drill pilings. So, just any other members have any other questions before I get started? Okay, thank you, Mr. Riley. Oh, Mr. Zachary. Yeah. So that being said, I've been down to your plant where you're making your ElectroMotion houses with the premier of the day, Mr. McLeod. What we found was the building, the time frame, and the shipping, and the burn proof. Like, it's unable to, the materials that you're using, it's safe for burning. I just want you to highlight on what I just brought up. Thank you, Mr. Zachary. Go ahead.
Thank you very much for the question. Correct. So the materials, we can include materials and coverings such that it's a flame retardant as well as mold retardant, these kinds of technologies and coverings on the structure itself. In terms of rapid construction or assembly, if you will, we have multiple factories that produce these SIP panels, 3 actually right now on standby. And once, again, it's all 3D modeled, and once it goes into their computer system and they start to produce these panels, it's a logistics, game that would be for where the panels are going, if it's going to be flown in, if it's going to be trucked in, barged in. These are really the logistics that would have to be worked out in terms of where it would be going from the factory to where the location is for final installation. The components that we include in the Revolution Housing Platform are very much robust and solid. It's near indestructible. The walls and such are very, very sturdy, and really depending upon what kind of requirements are in code, the wall coverings and such can be of your choosing and in terms of what code requires. Now, it was great to have you come down and the premier at the time. And again, what we were demonstrating to you was the fact that we have the technology, it's been operating, and we have the data as well. So we would be very, very interested in having that opportunity to collaborate and to even have a demonstration project as part of our efforts.
Thank you, Mr. Zachary. No, just to let the committee know that I've been working with Jai over the years as a MLA in regards to getting units for my communities that we're waiting for units, and we just don't see them coming quick enough. We have young families that we need and need units, and I think the biggest thing for me was the building in the time frame that we could do it, build it, they will come, basically model. So if we had an agreement, I guess, with the community corporations that I've been putting him in contact with the community corps in my riding of Nunukput to get them, trying to get them in a partnership to go forward to build units. So my goal as a member is 5 for Sax, 10, 10, 10 for Ulukaktuk, Paltuk, and Tuk. Then that's 35 units. That alleviates the pressure for me. That being said, then I'm looking at 2 elders facilities for Paulatuk and Ulu that I've been pushing for years, and I think build it, they will come. This model is because we're in financial strength with our funding with our territorial government already. But like I said, build it, they will come. Hopefully we could get a partnership with you, yourself, and the community to make something like this work and get something deployed down here even in the capital to show your product. So that being said, I mean, you're dealing with the Housing Corporation already. I know you're in talks with them, and hope that's going well. But I think this is where we're at. Where we're at is we really need units in the communities. We're in need, and this is what I see is one of the big products that we could help our people that we represent in the small communities and across our territory. So that being said, it's more of a comment to you, but if you want to add anything to that, go ahead, Mr. Zachary.
Thank you. Thank you very much. I actually have some video. If I could share my screen, I can show you some of the models that we have. The triplex, we also have a model with regards to the seniors, assisted living. I can show you that, and the unit that we have outside, if you're interested at all.
Yeah, Mr. Zachary, we'll give you 10 more minutes, that's it. So, show, please and thank you.
Thank you. Appreciate it. Give me one moment. No pressure, right? So what I'm going to do is I'm going to show the video of a walkthrough of the unit that we saw being set up by hand within a few days. So let me just, one moment. And here we go.
Blank screen.
All right. Okay. Should come up now. So this is a artist rendering, if you will. We have some cathedral ceilings. And then we have our triplex, which I'll just show you here now. This has 4 bedrooms per unit. So there's really a 12 bedroom per pod or triplex. I should also comment that these contain Revolution Energy technologies and the unique ventilation system that provides the ability to sterilize the air. And then here we have some images and video of our assisted living senior center. How is the video coming through?
Slowly.
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 It looks good.
So these are some of the designs that we have created based upon our Revolution housing platform and the energy technology. So again, what we're looking to do is have feedback, and we're able to create and design based upon our platform the type of structure that you may require. The housing really is lock up within a few days. For a larger structure like this, it would take more than just a few days. But really what can happen is as you get through the lockup, then you can start to heat it right away and condition it. The Revolution Energy technology then will provide the heating and the electricity for the structure, and that allows you to finish it even in some environments that are not conducive to finishing or to construction. And really what that does ultimately is lend and allow us to extend the time frame that is required for construction. So it allows us to push that envelope so that we can build more structures and deploy more, and we're not constrained so much by the weather and the environment. The seasons, if you will, right? There you go. Thank you.
Thank you, Mr. Zachary, for that. Really, that's the first time I've seen the what we talked about last year in regards to getting that design for the Elders facility, and I'm really excited for that, and look forward to when you're able to come north and to meet up with everybody here and in the communities. But for myself and committee, I don't see any more questions. I'd like to thank you tonight for. Thank you for your presentation to our committee. And seeing no further committee has no further comments or questions for you, I'd like to thank you, Mr. Zachary, for joining us tonight and presenting to us, and I look forward to working with you in the future. This concludes this portion of our meeting, public meeting. So there's a motion to just thank you. Have a good night.
Thank you too. I appreciate it.
Now this concludes the public portion of the meeting. Now I have a motion to go into camera. Mr. Johnson, thank you. Thank you, everybody.